Okay, I actually quite like these because I think that they're kind of easier. Well, depends on how you like fractions, but they're easier than you think. Now, I suggest that you go back and watch the video from the homework that I did on this. But this is how it works. The idea is this. If you have some regular graph here, okay, and you have, let's say, this is equal to y equals x squared, the parent function, okay? If you were to, if you were to increase the number in front here, and this is, remember, this is an invisible one right there. Let's say we increased it to 2. We were essentially doubling the number that you get out. Okay, so that means for any point that you go over here, you would normally on the parent function go up to here. Now you're going to go twice as far up because you doubled it. Okay, so you'll get this output point here twice as high, this output point twice as high, twice as high, twice as high, right? And all of those points getting higher and higher, right, makes it narrower. So the bigger the number that's in front of the x squared, the narrower it's going to be. Likewise, if we said, and I'm going to do this in green, if we took the parent function and we cut it in half, let's say we had, instead of the parent function, we had the new equation, y equals 1/2 x squared, then what you're saying is wherever you'd go over and normally go up to x, now you're only going to go halfway. So here, if we went over to -1, we'd only go halfway up because we're only taking half of the output value than we were before. Okay, half and half, half and half, and you get this wider curve because you're not going as high for any x value. Okay, what does that mean for us? Well, what that means for us is that, oh, and by the way, there's one thing that I wanted to say here. If I took the parent function and I changed the sign of it, so instead of, say, having y equals x squared, we had y equals -x squared. All that does is it flips it over. Every time you were going to go up, you go down instead, but you don't otherwise do anything different. So if it says positive or negative in front of it, that doesn't affect the width of it. And all we're talking about right now is they're asking for the widest and narrowest. Okay? And that, so we can ignore the negatives of this. That might have taken a minute to say, but now that we know it, we're going to move straight along with this. Okay? And there's a few of these, so we can move quickly through the other ones. So here's the idea. We don't care about the sign. We're just going to take the absolute value of these numbers. So I'm going to take the absolute value of 1/4, which is 1/4. I'm going to take the absolute value of -1/2, which is 1/2. Always positive, remember. And I'm going to take the absolute value of 3/2, which is 3/2. Okay? Now remember, the bigger number in front, the more it's going to be stretched and made narrow. So the lowest number closest to 0 will be the widest. They want to identify which of these three numbers is the smallest number. And if you don't know fractions, this wouldn't be obvious. If you do know fractions, it's crazy obvious that this is the smallest number, and therefore it's going to make the widest graph. Now, if you are struggling to say, why is that the smallest? It's got a bigger number on it. Then this is what I'm going to do for you. I'm going to write these all with a common denominator. Okay? So we're going to say, this is equivalent to, and let's use 4 as the denominator. So this is still 1/4. But now this one, if we put a 4 on the bottom, we have to do 2 times 2 to get here. So 1 times 2 to get us to 2/4. And same thing on the bottom. If we wanted to have a 4 on the bottom, we'd have to do 2 times 2 to make the 4. So 3 times 2 would make the 6 on top. And now you're saying the pieces are the same size. If you don't know fractions, you might not be aware that this basically says these are all pieces of the same size, pieces that it takes 4 of them to make a whole thing. So now that they're all the same size, we can say, well, then the one with more pieces is going to be bigger because all the pieces are the same size. So then we look and we say, aha, This is only one piece of that size. This is two pieces. That must be bigger. And this is six pieces that size. That's the biggest of all. Okay? Biggest number is narrowest when it's in front of the x squared term. So we know that the smallest number is going to be the widest, and therefore we got to list it first. This is the smallest number. Our list needs to have that first. So when we're looking through, this one has it first, great. This one has it first, great. The other two don't. So let's cross them out. We know that's the smallest one. Okay. Now the next smallest, well, it's going to be the next biggest numerator. Right? Here's one of those pieces. Here's two of those pieces. So we've got to go from having 1/4 to 2/4. 2/4 is the 1/2, or negative 1/2, right? So which one is that? That's this one here, C. And finally, then the last one would be 3/2. That's the biggest one, and that's C. Answer C has the order all correct from widest, lowest number, to narrowest, biggest number, as coefficients on the x squared term. Okay? We got three more like that, and we'll move through them quicker. Okay, so just like I said before, smallest number means widest. So let's look at the numbers. And I'm just going to circle the spots where the numbers are. We've got a 3, we've got an invisible 2, we've got an invisible 1, and we've got a 2. So what's the smallest? Well, 1 is the smallest out of the 1, 2, and the 3 numbers that we've got, right? So what's the smallest? 1. So we should have x squared listed first. C and D have that, but A and B don't. So let's cross those out. Oops. Sorry, I'm getting a little glitchy here. Sorry about that. So these don't have x squared first. They don't have that smallest number first. So they're out. They're not our answer. C and D do. But what's next? We have the next biggest, the middle size number. Okay? And it should go from smallest number in the front, which is widest, to biggest number, which is narrowest. And that is then C. We first have 1, then we have 2, then we have 3. Smallest to biggest. Coefficient of x squared means widest to narrowest. That's it. One more, we're done. Okay. Again, I told you this earlier. You can disregard the sign. We want the absolute value of this number is just 4. We want the absolute value of this number. It's just 3. We want the absolute value of this number. It's just 5. Okay. The one closest to 0, the lowest number, will be the widest. So which one's closest to 0? Well, 3 is closest to 0. So the one that has negative 3x squared first that's one of the answers that we want. And so B and D don't have that smallest number first. Okay. And then what's next? Well, what's next is 4. That's the middle size number. 4 is the middle size number, so which one has 4 next? And that's C, once again. Okay, this one doesn't, so it's wrong. And then, of course, the number with the largest absolute value, coefficient of negative 5, gives us the biggest number of 5, and that is C. So, C for all of them. Hope that makes sense. Smallest number means it's going the least high and therefore is the widest when you plot the y coordinates. And biggest coefficient, positive or negative, the furthest away from 0, stretches it the most and makes it narrowest.